Welcome to the St.Peters Engineering College, Department of Civil Engineering. Myself, V.GAJENDRA, Assistant Professor, Department of Civil Engineering. So I'm going to be teaching the subject Transportation Engineering for the fourth year, first semester. So in this session, I'm going to be discussing about the Unit 2 Geometric Design. Transportation Engineering subject, Unit 2 Geometric Design. So in the previous sessions, I discussed about we discussed about so historical development and highway development in India. So in the previous sessions we discussed about what is meant by the alignment and what are the factors influencing the alignment, and then what are the drawings and the reports that we are going to be preparing for the highway alignment, or we say that the highway project. Alignment is that the central line of the proposed road on the ground surface we are going to be called as alignment. That is, we are going to be called as alignment. For the alignment, so we are going to be preparing for the road to be constructed. The alignment is the first stage. We are going to be fixing up of the alignment on the ground. So the center line of the alignment, we are going to be provided center line along the proposed road. We are going to be prepared. After that, we are going to be doing the longitudinal sectioning and cross sectioning drawings we are going to be prepared. Longitudinal sectioning is going to be giving the profile of the ground along the length of the road. Profile of the ground along the length of the road, that is going to be gives you that the profile of the ground along the length of the road. And similarly, the road will be having length of infinite and width will be restricted length will be there. The road will be having length, width and depth. That is, the depth is going to be comprised of the total thickness of the pavement we are going to be provided. Thickness of the road we are going to be provided. So width also we are going to be doing by the cross-sectional survey or cross-sectional leveling. So we are going to be preparing the two important drawings while you are before going for the construction. After we are going to be selecting the alignment. After the proposed alignment is going to be fixed, proposed alignment of the roadway is going to be fixed. So then we have to do that, prepare the longitudinal drawing and as well as the cross-sectional drawing. What is the longitudinal drawing? That is going to be gives you that the profile of the ground along the length of the road. Based on that one, we can able to see that where the cutting is there and where the filling will be there. Means earthwork excavation, and make sure that we are going to be preparing the road surface is a flat one. So for along the length of the road. So next is going to be called width. We are going to prepare in the cross-sectional drawing. So here also width-wise also we have to be see that what is the profile of the ground. So what is the profile of the ground? So width-wise also we are going to prepare it. That comes from the profile cross-sectional drawing. Cross-sectional drawing and longitudinal drawing is going to be gives you that the profile of the ground along the length of the road and along the width of the road. So these are the prerequisites while you are going for the construction of a roadway or the highway. After fixing the alignment, preparing these drawings. In addition to that, various drawings also have various cross drainage works. Then we are going to be called as the retaining structures and other land acquisition plans. Also, we have to be prepared such that so we are going to be constructing of the roadway in a proper time. Construction of the roadway or the highway in a given time. These are all the drawings is going to be helpful. So longitudinal cross-sectional drawing. Then in addition to that one, through the alignment, whatever we given the proposed alignment, so any water body is going to be crosses, it is going to come across. So then we had to be constructed a bridge or the culvert. If it is going to be the obstruction of water body in a wider, then we are going for the bridge. If the stream is going to be come across for the alignment, proposed alignment, then we are going to be provided or we are going to be constructed as a culvert. So these are the important drawings. How many cross drainage structures? This is what we call cross drainage. So water body cross drainage structures comprises of bridge or the culvert, and as well as the side drains we are going to be provided. So all these we are going to be calculated. All these we are going to be prepared. Then it is going to be influencing under the total cost of the construction. So then we are going to be where the material is going to be available. Always for the construction, we are going to be using local available material in such a way that we are going to be minimize the total cost of the construction. So the material availability plan, that is going to be called as quarries, where the quarries is going to be available, local availability materials with respect to the soil as well as the aggregate, stone aggregate, where it is going to be available. all that we are going to be getting the information is going to be called as the drawings that is going to be prepared. We can get the availability of the materials in the vicinity of the project, nearby the project. These are the things. These are the things we discussed in the previous sessions. And today's session we are going for the geometric design. What is meant by the geometric design? What are the geometric design? So the elements we are going to be provided for the highway or the roadway construction. After we are going to be done the alignment, and then we are going to prepare the drawings. Prepare the drawings is over. So next part is going to be called as reality in the construction. That is going to be called as geometric design. The term itself is going to be is going to be called geometrical features. Geometrical design is going to be called as geometrical features that we are going to be designed for the highway or the roadway is going to be called as geometrical design. Then what are the geometrical features or what are the geometric design? Actually, first we are going to preparing the planning. Planning is over. Then we are going for the design. After the design, then we are going for construction. These are we are going to be called as phases of the work. So planning, design, then the construction, then the maintenance, then the rehabilitation. The first part is going to be called as a planning. According to the requirement, you have to plan. Then we have to go for the design, various elements of a road or the highway. After design is completed, so then we have to go for, so the implementing that the geometry design into that the field is going to be called as construction, reality in the construction. So then the construction is over, then we have to go for proper maintenance is going to be required for any constructions, or you can say that the any infrastructure projects. So the maintenance will be required. After that, the maintenance, we have to go for the rehabilitation. So rehabilitation. These are the various sequences or the stages in the construction process. Now then we are going for the, what are the geometrical features? Why the geometric design is going to be required? So the geometric design is going to gives you that the one is going to be called as already the visible features, that is alignment, side distance, and intersections. So the geometrics of highways should be designed to provide optimum efficiency in traffic operations with maximum safety and reasonable cost. So this is geometrical design is geometrical features we are going to be provided. For example, we have to go for geometrical design. Geometrical features is width of the road is one of the geometry. Width of the road. How much width we are going to provide it. This is going to be based upon that the traffic volume and traffic capacity. Width is going to be fixed. And thickness of the road or the thickness of the highway pavement. How much thickness we have to be provided. So this is also we are going to say that the load is going to be coming from the traffic. So that is the traffic volume. What is the traffic volume there? So then it is going to be called heavy traffic volume or medium traffic volume or the low traffic volume. So based on that one, we are going to provide the thickness. So width of the road, so the thickness of the road, and if the alignment is going to be changes their direction, then we are going for the curves we are going to provide it. In the horizontal or the flat terrain, that we are going to call as horizontal curves, and then it is going to be called as the terrain is going to be changes, hilly terrain or the mountainous terrain, then we are going to be where the alignment is going to be changes from straight to the other direction. Whenever alignment is going to be changes because of any obstruction, so then we are going to be, so the necessitated by the curve we are going to be provided. So that the horizontal profile, we are going to provide the horizontal curves. In vertical profile, we are going to provide as a vertical curves. Then what is the side distance? What is the distance is going to be available, visible to the driver. So we are visible ahead to the driver such that he can able to travel very safely. So that is what we are going to call also the one of the geometrical design elements is going to be called as side distance. So alignment, side distance, and intersections. How we are going to be designing the intersection such a way that so we are able to get there is no collision is going to occur. So that is also more important. The geometrical features we are going to provide in the intersections is going to be called as with the signaling system, or we are going to be providing with the roundabouts we are going to be provided. But in addition to that one, we are going for the design controls is that speed is the one of the control and traffic volume is going to become one of the control. So these are the various control. While you are traveling on the road, speed is one of the criteria. You are going to be controlling the speed, and similarly the traffic volume you have to be controlled. Then automatically, so you are going to be saving the saving the travel time, and there is no, so the blockage of the traffic is going to be taking place. So that is we are going to call it geometrical design. Geometrical design is going to be comprises of one is going to be called as alignment, So that is the camber we are going to provide it, width of the road we are going to be provided, and depth of the, what is the height of the road we are going to be provided, and what is the side distance, and what are the intersections. These are all we are going to be called as the geometric design. If you are not done properly the geometric design, so what is going to be happen? Operational, so the cost is going to be increases. If you're not done properly the geometric design, efficiency of the vehicles, that is road user or road vehicles is going to be increased. So that is going to be called as the vehicle operating cost is going to be increased, and is going to be no safety. So it is going to be leading to that the accidents. You are not done geometric design properly, it is leading to that the accidents. Vehicle operation cost is going to be increases, and total cost of construction also is going to be increases. So this is going to be influencing on the geometric design. If you done geometric design properly, we can able to economical that the total cost of the construction, economize the total cost of the construction. So we can avoid as much as possible that is the accidents, and we can avoid, we can able to reduce that the vehicle operation cost. So that is going to be influencing the geometric design. Vehicle operation cost, total cost of the construction, total cost of vehicle operation cost, total cost of the construction, and safety of the road users. So that are all we are going to be reducing the accidents. This is going to be happen once you are going to be properly designed that the geometrical elements that we are going to be called as geometric design. Geometric features of the roadway, we are going to be designing that we are going to call a geometric design. So that we are going to be given geometrics of highway should be designed to provide optimum efficiency in traffic operation with maximum safety and reasonable cost. So that is economical cost one. Then designer may be exposed to either planning of new highway network or improvement of existing highways to meet the requirements of the existing and the anticipated traffic. This is also comes as a geometric design. Not only for the new road construction, so we are going for existing highway, so we are going for the maintenance, how we have to do that the maintenance or the improvement of the existing highways, so depending upon the anticipated traffic. Depending upon the anticipated traffic, we are going for improvements or extending of the existing highway. That is also comes under the highway geometric design. So geometric design of highway deals with the dimensions and layout of the visible features of the highway, such as alignments such as highway distance intersections. Geometric highway should be designed to provide optimal efficiency. Then the geometric design of the highways deals with the following element. What are the one is going to be called as with relate to the cross section. That is going to be called cross section elements. The considerations for the width of the pavement, formation of the land, the cross slope of the pavement comes under the cross sectional elements. Width of the pavement, or we are going to call it as width of the road. Formation and land. Formation width is going to be total land will be required for the road formation. Then the cross slope we are going to call as camber. Camber we are going to provide. You can able to see that at the center of the road, the crown. So we are going to be provided the slope we are going to provide it, and towards the edges. So towards the edges will be, it is going to be slope we are going to provide. At the center we are having the crown point, such that the rainwater can able to drain off. Water can able to drain off easily in the case of rainfall. That is we are going to call a cross slope. That is the first one we are going for designing is going to be called a cross section elements. Then side distance considerations. So here the side distance is, so the distance visible ahead to the driver to stop the vehicle without any collision is going to be called a stopping side distance. To stop the vehicle at any instant of time. To stop the vehicle at any instant of time, the object is going to be suddenly come across. So that we are going to call a stopping side distance. Similarly, we are going for overtaking opportunities we are going to be provided for the fast moving vehicle to overtake the slow moving vehicle. So roadway is going to be provided means it is going to be combination of slow moving vehicles will be there and fast moving vehicles will be there. So the opportunity we are going to be provided, that is going to be called as the distance, safe distance we are going to be provided to take care of that the overtaking operations along the length of the road, along the length of the highway. We are going to be provided means enough width we are going to be provided. So that is the width of the pavement or the width of the road we are going to be provided such that, so without collision they can able to take that the overtaking. The fast moving vehicle can able to overtaking the slow moving vehicle. Then horizontal alignment details. With reference to that, the horizontal alignment is going to be called horizontal curves and super elevation. That is in the flat terrain. Horizontal alignment is going to always, it is going to be called a flat terrain. And vertical alignment always is going to be called as vertical terrain. The terrain is going to be changes. So then, so the in that the alignment is going to be changes. We are going to be introducing that the horizontal curves. It necessitates that the alignment is going to be straight to the other direction. It is going to be deviated. The curvature we are going to be provided. The curvature is going to be designed. We are going to be called as horizontal curve. And similarly, super elevation is going to be, if the curve is going to be provided, we can able to see that one inner edge that will be lower level and higher edge will be at the higher level, such that the vehicle can able to road vehicle can able to negotiate the curvature with safely without overturning. That is known as super elevation. Super elevation meaning that how we are going to be design a super elevation means if we are going to be design the curve in the horizontal plane, while it will be traversing a horizontal curve, the road vehicle, it is not going to it is not going to overturn. Tilting of the vehicle is not going to be happen. So in such a way that we are going to be designed is going to be called a super elevation. Means inner edge of the road is going to be the lower level and higher edge of the road. Other edge of the road is higher elevation. That we are going to call a super elevated or elevation. The term itself is going to be giving you as meaning. Then vertical alignment details. This the terrain is going to be called as mountainous terrain or hilly terrain. So in that also we are going to be constructing the roads. In that, so we are not able to go for the straight alignment. It is going to be deviated depending upon that the excavation and filling. So then the vertical curves are going to be provided. Our vertical curves are designed. Always either a horizontal curve or the vertical curve. When we are going to be designing is going to be called alignment is going to be changes its direction. The change of alignment is always necessary at the curvature. If it is in a horizontal plane, we are going to call as horizontal curve. If it is in a vertical plane, it is going to be called as vertical curve. Similarly, the gradient is going to be provided in the hill. We can able to see that the elevation is going to be changes. Elevation is going to be changes, then we are going to be provided with that the gradient. So the gradient we are going to be provided in such a way that so the road vehicle can able to climb easily. Elevation that is going to be called gradient we are going to provide. The slope we are going to provide it. So the road vehicle can able to climb very easily. In that direction we are going to be designing the gradient. The gradient is going to be called a slope provided to the roadway or the highway in the mountainous terrain and hilly terrain, that we are going to be called as gradient. That we are going to provide the gradient to avoid the cost of construction. If we are going for if we are not going to be provide the gradient, then we have to go for the earthwork. More earthwork has to be done to go for excavating that the hill or the mountain. It will go for the high construction cost. So that's why. So we had to be limited or we had to be minimized that the construction cost. We are going to be designed that the gradient in the hilly areas or the mountainous areas. That is going to be slope is going to be provided from one end to the other end. The gradient should be designed in such a way that it has to be climb the vehicle. We have to be see that what is the power of the engine of a vehicle. Based on that one, we are going to be designing that the gradient such that can able to so the climb the gradient very easily. If you are going to be provided a steep gradient, what is going to be happen? Vehicle operation cost is going to be increases. Steep gradient we are going to provide. So always preferably we have to go for as far as possible the flat gradient we are going to be maintained in such a way that any type of the vehicle can able to climb easily. That is we are going to be called as vertical alignment with gradient. So these are all we are going to be called as the geometrical features. So we are going to be designing for the roadway or the highway. One is cross-section elements. Second one is side distance considerations. Third one is horizontal alignment details. And fourth one is vertical alignment details. Now we are going for the first one is going to be called a cross-sectional elements. What are the cross-sectional elements? We are going to be designing for the roadway or the highway is first one is going to be called as carriageway. So then the shoulders, then the formation width, then the right of way. So and in addition to that one we are going to be provide the camber or the cross slope provided, that we are going to be called as comes under the cross-sectional elements. Cross-section elements are that we are going to be we are going to be designing for the highway or the roadways. One is carriageway, shoulders, formation width, and right of way. Now we'll go for discussing one by one. So what is meant by the carriageway? What is meant by the shoulders? What is meant by the formation width? What is meant by the right of way? So the carriageway, or we are going to call it width of pavement. Why the name is given carriageway is it is going to be carrying that the roadway vehicles, carrying the roadway vehicles. That's why the name is going to be provided as a carriageway, or we can say that the width of the pavement. So what is the width we had to be provided? What is the width we had to be designed? For that, we require that first is going to be called as how many lanes we are going to be provided, or it is going to be depending upon that. Mainly, we are going to be, it is going to be depending upon that the traffic volume. Your carriageway width or width of the pavement is going to be deciding by the traffic volume. If the traffic volume will be high traffic volume will be there, then you have to go for width of the carriageway is more to be provided in such a way that so there is no interruption of the thorough vehicles, there is no interruption of the, there is no traffic jams has going to be taken place on the roadway or the highway. So that is the main important factor we are going to be considering is going to be called as the traffic volume. So the width of the pavement or carriageway depends on width of the traffic lane, means how many lanes we are going to be provided, number of traffic lanes required. Then the carriageway intended for one line of traffic movements is called as traffic lane. Carriageway intended for one line of traffic movement is called traffic lane. What is meant by the traffic lane and how many number of traffic lanes were? If you see that in the construction of the road, in the roadway while you are going to be traveling, so the broken white lines were going to be provided. So that is going to be dividing your carriageway. So if it is broken white lines, white paint we are going to be so put onto the road, then it is going to be giving us two-lane road. Two-lane road. There is no broken lines were going to be provided, or there is no median were going to be constructed, then it is going to be called a single lane. Almost traffic lane will be single lane will be there in the villages. You can able to see that in the villages where the traffic volume will be very low. That's why single lane carriageway is going to be sufficient enough. If you are going to come to urban roads, it will be a two-way or the two-lane or three-lane road. And similarly, if you go for the intercity roads, we are going to be provided with the two-lane, three-lane, or the four-lane roads. We are going to provide it. So that is how we are going to fixing the carriageway or the width of the pavement is the traffic volume. Then we are going to be dividing into that the number of lanes. Because we are going to avoid the crisscrossing of the traffic. We are going to provide the lane discipline. Lane we are going to be designed. The total width of the pavement is going to be divided into the one lane, or the two lane, or the three lane, or the four lanes, such that the traffic can able to move safely. So the number of lanes required in a highway depends on predicted traffic volume and the traffic capacity of the each lane. That already I discussed about that. So it is going to be completely based on that the traffic volume. It will be reflected how we are going to be designing the width of the pavement or the carriageway depending upon the traffic volume and as well as traffic capacity of each lane. So the lane width is determined on the basis of the width of the vehicle and minimum side clearance required for the safety. So first one is going to be called as the traffic volume. Then we can see that the second one is going to be called as dimensions of the vehicles also is taken into the consideration. Based on that one, you are going to be provided that the width of the pavement or the carriageway. So one is the traffic volume. Second one is the dimensions of the roadway vehicle. Dimension of the roadway vehicle. So the roadway vehicle will be having different dimensions are there. If you take that the bus, if you take that the lorry, if you take that the car, so that is the car comes under the light motor vehicle. Light motor vehicle will be having with the dimensions will be different, and heavy motor the medium weight vehicles are going to be different. If you take that the van, or if you take that the bus, if you take that the truck, the dimensions is going to be vary such that we are going to be satisfying that the minimum requirement. So based on that one, we are going to be fixing that the width of the carriageway or the width of the pavement. How we are going to be designing? A lane width of 3.8 meters is considered to be sufficient for vehicles of 2.44 meters maximum width. So maximum width is 2.44 meters. We are going to be taken into the consideration. So they are going to fixing that the lane width is 3.8 meters. 3.8 meters is one for the one single lane. Traffic lane, one lane traffic or one lane road, single lane road will be having that the pavement width is going to be called 3.8 meters. 3.8 meters constitutes sufficient for vehicles of 2.44 maximum width. If a single lane of carriageway of 3.8 meters, provided side clearance of 0.68 meters would be obtained. So that is the dimensions is 2.4 and clearances on the way, clearances on the both sides of the vehicle. Is width of the vehicle is 2.44 and the clearance we are going to provide 0.68. Is provided a side clearance of 0.6 meters, should be 0.68 and 0.68. Altogether, we are able to get the 3.8 meters. Now we can able to see in the diagram how we attained that the 3.8 meters. We can able to see that so the 2.44 meters and as well as the 0.68 or 68 meters is the clearance will be there. So this 2.44 68 centimeters 68 centimeters and 68 meters altogether we are able to get the width of the pavement is 3.8 meters. Width of the pavement is 3.8 meters for single lane road. For single lane road is going to be called as 3.8 meters is the width. Then for pavements having 2 or more lanes, width per lane is 3.5 meters. Previous case is 3.8 for single lane, and for even more than one lane we are going to provide a 2 lane, 3 lane or 4 lane. So what is the width of the pavement we are going to provide is 3.5 meters. In the case of 2 lane pavement of width 7 meters, the minimum clearance between 2 lanes of traffic would be 1.06 meters for widest vehicles on the road. So what is the width of the vehicle for 2 lane road is we are going to provide is going to be called 1.06 meters. How we are going to be arriving that 3.5 meters with for multiple lanes, then it is total is 7 meters we are going to be designed. 7 meters is going to be designed based on that the traffic, the clearance between the 2 lanes of traffic will be 1.06 meters and the same width of the vehicle we are going to be considered. Now we can able to see that 1.53, 106 and 10. So 53, 53, 106, 106 centimeters distance between the vehicles and clearance is 53 centimeters and clearance at the outside clearance is 53 centimeters. Width of the vehicle is 2.44 meters, 2.44 meters. Altogether, we are able to get that the 2 lane road will be having that the width of the maximum width we are going to provide is going to be called as 7 meters. So 7 meters we are going to be designed based on the clearances and as well as the width of the vehicle. In some highways, traffic separators or the medians are provided between 2 sets of traffic lanes intended for traffic moving in opposite directions. In highways with traffic separators, the road width depends on pavement width of the traffic separator. So yeah, while you are going to be how we are going to be dividing that the lane width, whether it is going to be so painting with the white color or otherwise so the traffic barrier we are going to be constructed. That is going to be called a permanent construction we are going to provide it. That we are going to call it as median. Median we are going to provide with the cement concrete. So the permanent construction we are going to be done. Or otherwise temporary is that we are going to painting that the painting with white color. That is going to be called. Already I told you that. So the broken white lines, white painting is going to be giving as that it is going to be so the lane divided and the overtaking is done. Overtaking can able to overtaking is going to be taking place. Overtaking side distance is available. If it is thick line, we are going to provide means overtaking is prohibited. If broken lines will be there, so overtaking chances are there. Overtaking opportunities they are going to be provided in a particular highway or the roadway. So then what are the width and height of the vehicles of different types of the vehicles by using the in the roads is as per IRC Indian Road Congress 8693 and Indian Road Congress 3 maximum allowable dimensions of the vehicles. So this is the basis we are going to be the making the width of the pavement or we are going to be designing the width of the pavement. Based on this one, almost all we are going to be designing the width of the pavement or the width of the carriageway. Width is 2.44 meters, maximum width of the vehicle 2.44 meters. Height of the vehicle is for single deck 3.81 meters, for double deck 4.72 meters. Length of the vehicles with 2 axles 10.6 meters, 6-7 meters. More than 2 axles will be there 12.19 meters. Tractor with semi-trailer 15. Means trucks, heavy trucks 15.24 meters. Tractor with trailer 18.29 meters. Length of the vehicle maximum is 18.29 meters with the heavy trucks. And then similarly, height of the vehicle is 4.72 meters is the maximum height, and maximum width of the vehicle is 2.44 meters. This is we are going to be taken the guidelines from Indian Road Congress specifications for the road vehicles, road vehicles. Then based on that one, we are going to be designing that the width of the road or the width of the pavement or the width of the carriageway. Then next one is the next cross section element we are going to be designing is going to be called as shoulder. So the term itself is going to be giving a meaning shoulder. How the person will be having the shoulders. It is going to be giving the support to the entire human body itself. Support we are going to be getting. So that the assistance we are going to be getting from the shoulder. Similarly here the roadway also we are going to be designing the shoulders after the besides the width of the pavement. Besides the width of the pavement, the shoulder is going to be designed. So the purpose is that why the shoulder is going to be required. If any vehicle is going to be damaged, that vehicles can able to park in that the shoulder. It will be not interrupting that the thorough traffic. So your damaged vehicle can able to park on the shoulder. That is one purpose the shoulder is going to be designed. Another purpose is that sometimes, so the width of the carriageway is not sufficient for the overtaking operations. The shoulder can able to do. So shoulder also we are going to be providing the pavement, but they are not providing with the surfacing. Sometimes they are going to provide with the surfacing. Sometimes they are not going to be provided with the surfacing. Surfacing means so we are going to provide the bitumen layer or the concrete layer, or otherwise sometimes they are going to be leaving with the, as it is with the soil or the earth as it is as the shoulder, because the major traffic will be moving on the carriageway or the pavement, but in emergency cases only we are going to be using the shoulder. That's why we are not going for the surfacing. Surfacing is not going to be required. Only we are going to be keeping that the damaged vehicles, or otherwise in case of exceptional cases, in case of emergency, so you take that extra width for the overtaking operations. Shoulder. So width of the carriageway is extended on either side in the form of the shoulder. So already I told you that. So the carriageway is extended on either side in the form of the shoulder. Shoulders are provided. What is the purpose? Objective is of the shoulders is to act as a service lane for the vehicles which are broken down or damaged. So the vehicle is going to be broken or the damaged. If you are going to be keeping it on the road as it is going to be interrupting the traffic. So that's why we are going to be take it out and putting into that the shoulder. We are going to parking on the shoulder. So that for that purpose the shoulder we are going to be using. Then to serve as an emergency lane for the vehicle which has been forced to move out of the pavement. Emergency lanes are overtaking operations. Also we are going to be utilizing that the shoulder. The minimum shoulder width recommended by the Indian Road Congress is 2.5 meters. So now itself we discussed about width of the pavement or the carriageway for the single lane road is 3.8 meters, and width of the road or the width of the lane for the carriageway for the two lane is 7.7 meters. And the similar way, Indian Road Congress is going to be given the specifications for the shoulder is the width of the shoulder is 2.5 meters. 2.5 meters is going to be provided such that it has to be utilized for parking of the damaged vehicles, and also we are going to be using for the emergency lane for overtaking operations. Desirable width of the shoulder is 4.6 meters. Up to we can go for 4.65 meters. So the width is 2.5 meters is the minimum width we are going to be provided. Then next another cross sectional element is going to be called as a curb. So the curb is going to be called as a boundary between the pavement and shoulder or the footpath. So like that, we are going to be laying the stones on edge, indicating that. So that is the end of the pavement, and so end of the pavement. Then next onwards, the shoulder is going to be taking place, or it is going to be end of the road boundary. Road boundary is going to be indicating that the curb. And then after that, we are going to be keeping the footpath. So that is going to be called as pedestrian traffic. Footpath is going to be provided for the pedestrian traffic. So what are the types of the curbs? The curbs is going to be designed for low curb. Class 1 are the low curbs. Class 2 are low speed barrier curbs. Class 3 are the high speed barrier curbs. So that is depending upon the traffic volume and depending upon the type of highway we are going to be designing the low or the low speed barrier or the high speed barrier curves. So indicating that the driver can able to understand that. So what is the boundary of the road, and beyond that the boundary we are having the shoulder, and beyond that the shoulder we are having the in case of the so the urban traffic, we can able to see that the footpath we are going to be designed for the pedestrian traffic. So that is the one another cross section element we are going to be designed is going to be called as a curb. Then what are the width is going to be available for national highway and state highway, major district road MDR, ODR other district road and village roads. So what is the curbs we are going to provide? Double lane width raised curb is 7.5 meters, 7 meters and 3.5 meters per lane. So this is the width of the carriageways we are going to provide. And the curb, what is the height of the curb we are going to provide. Next one is going to be called the formation width. Means total width of the pavement, how much will be required. So this is more important while you are going for the new highway project. Reason is that once the road is going to be constructed, so the besides the road, so or we can say the abutting the road, so the development will be taken place very fast. So the rapid development is going to be taking place beside the roads. Once the road is going to be developed or the highway is going to be constructed, so the side of the road, the development will be very fast, rapid way is there. Now in future, we want to extend the road facilities. It is not possible. It is very difficult. So we had to be go for land acquisition, and we had to be give the compensation for the so wherever the property is going to be there for the facility, we are going to be extended roadway facility. We are going to be extended. So this is going to be occur. That's why. So yeah, we are going to be taken into the consideration of future for 5 to 10 years. The formation width we are going to be acquired. The land is going to be acquired for total width of the formation. Total width of the, that is we are going to be called width of the roadway. So for the future also we are going to be taken into the consideration. Then we are going to be acquiring the land to go for the new highway project. For existing highway project, obviously we can go for the extension, means we have to go for the land acquisition has to be done. If you are going to be purchasing in advance the land for future, so then there is no acquisition will be required in the future. So that we are going to be called as formation width. The top width of the embankment or the bottom width of the cutting is known as the formation width or the width of the roadway. Formation width is the width of the pavement carriageway plus width of the shoulder on either side. Altogether, we are going to be called as formation width. Pavement carriageway plus as well as shoulder also we have to be considered. This is that the total land will be required for you have to go for a construction of a roadway or the highway. So that we are going to call a formation. We are going to form the road. Either it is going to be embankment or into the cutting. Then what are the standard formation widths as per the IRC? Plain terrain and as well as mountainous steep terrain. Single lane is 12 meters, two lane is 12 meters in the case of national highway and state highway. Major district road 9 meters and 9 meters, other district road 7.5, 9 and 7.5 meters, village roads. If it is in mountainous and the hilly terrain, always we are going to be width of the road is going to be restricted because of landsliding and with difficulty in the construction. That's why national highway and state highway, it is 6.25 meters of single lane and 8.8 meters for the two lane. And for major district road, 4.75 meters, other district road 4.75 meters, and village roads 4 meters. In the case of mountainous and steep terrain, in the case of plain terrain is going to be different. These are the standard formation widths as given as per the IRC. So now it is going to be called as the right of way. Another cross-section element is going to be called as right of way. Right of way is the area of the land acquired for the road along its alignment. Total. So width of this acquired land is known as the land width. And further, what are the factors governing the land width? So that is the right of way is that the total land, in addition to that the carriageway and the width of the shoulders. And for the future extension purpose, anything will be required that we are going to be, acquired, that is going to be called as formation. So that we are going to be called as right of way. Width of the formation depending on the category of the highway and the width of the roadway and road margins, height of embankment or depth of cutting, which is governed by the topography of the vertical alignment, side slopes of the embankment. What are the recommended land width of different classes of roads? So this is the right of way. Right of way is going to be called as for the future development also. we are going to be acquiring the land that we are going to be called as right of way. The formation width plus the feature extension. Formation width plus feature extension is going to be called as right of way. So if you take the open areas, it is 45 meters. Normally 30 to 60 meters. Built up areas 30, 30 to 6 in national highway and state highway. And major district roads 25 to 30. Other district roads 15 to 25. Village roads 12 to 18 meters. In the mountains terrain, 24 or 20, 15, 12 and 9. These are so the right of way we are going to be acquired for the road construction. So this we can able to see that the cross section of a road in embankment is called the width of the right of way. What is the right of way is all together we are going to provide. This is the carriageway, shoulder and the road margin. From here to here it is going to be called road margin. We are going to be leaving formation width plus more road margin on either side to go for the plantation, and as well as the side drains we are going to be designed. Side drain we are going to be designed. Altogether, this is we are going to be called as width of right of way. Width of right of way. Right of way is going to be called as total land acquired. In addition to that, the formation width, that is carriageway and shoulder plus road margins together, we are going to be called as so the width of the right of way. So this is the road in cutting. So the crossing 2-lane national highway or the state highway and rural highway is total land width is 50 meters is going to be there for national highway or the state highway. Cross section of 2-lane city road in built up area. City road, how it will be there. So pavement width, footpath, and the curb we are going to provide it. Now the cross section on divided highway in urban area. Then the last cross section element is going to be called as a camber. So what is meant by the camber? What is meant by the camber and what is the purpose of the camber and how we are going to be designing. So camber is going to be called as a cross slope. Yeah, on the way we are going to cross slope to the road surface in the transverse direction to drain off the rainwater from the road surface. You can see that the profile, there is a crown at the center will be height we are going to provide, elevated portion we are going to provide. Once from the center to you are going to reach into the edges, we can able to see that the slope will be there. That is we are going to be called as camber. We can able to see that in the diagram. So this is the crown portion and sides we are going to provide a slope such that water can able to drain off very easily. The rainwater can able to drain off very easily because the slope we are going to provide. If there is no slope we are going to be provided, there is a camber is not going to be provided, the water will be stagnated on the road. So then it is going to be deteriorating the road surface. It is going to be damaging the road surface. So water is continuously stagnated and the movement of the traffic and as well as with the water. So the road will be damaged and it is going to be forming potholes. That's why the camber is going to be provided. In addition to the camber, we are going to provide that side drainage system such that it is going to drain off the water from the pavement or the road. Then it is going to be leaving to the side drain system, and with the side drain carrying the water and disposing it off. So this is the link, the stages we are going to provide. Camber. Camber is also called a cross fall or the cross slope or the transfer slope. Usually the camber is provided on the roads by raising the center of the carriageway. This is the raising the center of the carriageway with respect to the edges forming a crown or the highest point of the center line. So that we are going to be called as camber. Then you can able to see that one in the diagram. So this is the road surface, edge of the road is the crown, and this is we are going to call as the camber. How much cross slope we are going to provide it with the width of the road. So the camber or the cross slope for the road surface. So we can able to see that this is the crown and this is going to be the how much. So the thickness we are going to provide, the height, how much elevation we are going to provide is going to be called as camber. That's why we are going to call it cross slope, the road surface. Then necessity of the camber. So we discussed that to drain up the surface water. The water will be stagnated on the road surface. It is going to be damaging the road surface. It is going to be forming the potholes. That's why as quick as possible to drain off the surface water to prevent the entry of the surface water into the subgrade soil through the pavement. To remove the rainwater from the pavement surface as quickly as possible and to allow the pavement to dry soon after the drain. For these purposes, the camber is going to be provided to separate the traffic in two directions. There is another way also we are going to be getting that the directions of the traffic to separate the traffic in two directions is going to be acting as a lane separator. Acting as a lane separator, main objective is that one the camber is going to provide to drain the surface water. To drain the surface water, that is the main objective or the purpose we are going to be designing the camber. If it is going to be water is going to be stagnated, it is going to be damaged to the road surface. Damaging in terms of potholes is going to be so developed, and it is not going to be giving that the smooth riding capability for the vehicles. So the vehicles got damaged, and sometimes it may be lead to the accidents also because of the potholes. So that is the for that purpose we are going to be using that the camber is going to be designed to improve the appearance of the road. So the how we are going to express the camber. The rate of camber is usually expressed 1 in n, which means the transverse slope in the ratio of 1 vertical to the n horizontal. Horizontal dimension is going to be called as infinite. That's why we are going to be called as n. Vertical distance is going to be called as 1 because it is unit 1, same unit. So vertical distance is not going to be changes, but horizontal distance is going to be infinite length. Length of the road will be infinite length. So that's why n is the horizontal and 1 is the vertical. 1 in n we are going to be expressing that the necessity of the camber or the slope we are going to provide with respect to that the horizontal. Camber is also sometimes expressed as a percentage of the road width. That is 2.5% means the mean of that 100 meters width of the road and height of the crown will be 2.5 meters. 2.5 by 100 is going to be called as 2.5%. 100 meters of the width of the road. The vertical ordinate is going to be called as 2.5. Slope is going to be 2.5. The rate of camber depends upon type of pavement surface. What is the pavement? Whether it is going to be called a bituminous surface or whether it will be a stone aggregate or whether it will be earth road surface we are going to be designed. Based on that one, we can go for the slope, cross slope we are going to provide. Whether it is going to be a cement concrete road. Amount of rainfall also. One is pavement surface, another one is going to be called as amount of rainfall. If they say heavy rainfall area will be there, we have to be provided the so camber, appropriate camber were provided such that the rainwater can able to drain off very easily. And also we have to be taken care of that the pavement surface. If it is cement concrete, sometimes it will be very difficult. Bituminous pavement is okay. Earth road and the gravel roads is also is difficult to maintain that the camber. So we have to be see that. So based on that one, we are going to be designing that the camber. One is so it is going to be pavement surface. We will be looking into the pavement surface. Other factor to be considered is going to be called as amount of rainfall. Factors governing camber for impervious pavement surfaces like cement concrete or bituminous concrete, flat camber is enough. For pervious surfaces like waterborne macadam or earth roads, which may allow surface water to get into the subgrade soil, steeper class slope is going to be required. Because bituminous road and cement concrete are the impervious layers. Impervious layers. So even if water is stagnant, also it will not percolating into the lower layers. And to get that the damage of the surface. It will be allowing the damage of the surface. So that's why for the we are going for the cement concrete surface and the bituminous surfaces is somewhat lesser. And if you go for earth road and gravel roads, it has to be more gradient wagon provided. More camber is going to be provided. Steeper camber may also be provided in areas of heavy rainfall. So then these are the recommended values of the cambers for different road surfaces. Now we can able to see that cement concrete and high type bituminous surface 2%, maximum is 2% and minimum is light traffic will be there 1.7%, 1 in 60 to 1 in 50, 1.7 to 2.5. While you are going to be coming to the earth roads, you can able to see that maximum we are going to provide because it is pervious layer. Earth is going to be called a pervious layer. The water will be percolating into that the pervious layer and the damage is going to be severe damage is going to be occur. Here in the case of cement concrete or the bituminous surface, it is impervious layer. The water will not percolate into the lower layers and damage is lower. Damage is going to be less. That's why. So we are going to provide the less camber in case of cement or the bituminous one, and more camber we are going to provide in case of gravel, waterborne macadam and gravel road and earth road. So cement concrete and height of bituminous surface 1 in 50 to 1 in 60, that is 1.7 to 2%. And thin bituminous surface 1 in 40 to 1 in 50. Waterborne macadam and gravel road 1 in 33 and 1 in 40. Earth roads 1 in 25 and 1 in 33. So these are the recommended values of camber for different types of the road surfaces by the Indian Road Congress. So concrete will be concrete and bituminous. We are going to be provide the less cross slope or less camber. And in the case of earth road and gravel roads, we are to be provide more camber. So because of it is going to be called as pervious layers. So with this, we are going to concluding this session. We discussed about that the cross-section elements for in this session. So what are the various cross-section elements is going to be called as width of the pavement or the width of the carriageway, the shoulder, formation width, right of way, and the camber. So next session we are going to be discussing about that the side distance requirements. Side distance requirement. So geometrical design will be having that cross-sectional elements. Then another one is going to be called as the side distance requirements. Then another one is going to be called as the horizontal element requirements and vertical element requirements. These four are we are going to be called as geometrical features that are going to be designed for the highway or the pavement. So that's why we are going to call it geometrical design. Geometrical design comprises of the cross-sectional elements, side distance requirements, side distance elements, horizontal alignment elements, and vertical alignments. So thank you.